right, so how do we get these anaerobic cells, aerobic cells? How do we get these endospore forming cells? So there is a theory that describing how eukaryotic cells came to be. And when we go back, the simplest form of a cell is a prokaryotic cell. Now back when prokaryotes ruled the world, our oxygen concentration was very different. The gas components in the atmosphere were very different, and there were a lot of prokaryotic cells, and many of them were anaerobic. The predominant ones were anaerobic because there wasn't much oxygen at the time. So this is what was living, a primitive prokaryotic host cell, anaerobic in nature. As things started changing, it allowed for life that used oxygen. So there were aerobic bacteria that developed, that were capable of using oxygen to make ATP. And they existed side by side for a long period of time. But over time, the oxygen requirements were getting more and more, oxygen percentages were getting more and more, and aerobic bacteria had an advantage. The aerobic bacteria were smaller at first, and some of these aerobic bacteria got swallowed up by these larger prokaryotic cells. Again, a larger cell, endocytosis, takes in this aerobic bacteria, but instead of dying, the aerobic bacteria survived inside that cell and kept living, replicating, producing ATP by using oxygen. That ATP was used by the aerobic bacteria, but it also started being used by the prokaryotic, the anaerobic bacteria as well. So I have a symbiotic relationship. Two organisms living together, both benefiting. The aerobic bacteria was living in an environment where it had more protection, and in exchange, the aerobic bacteria was producing more ATP that it was sharing with these anaerobic bacteria. So that's good. Over time, these two symbiotic organisms that were dependent on one another became so dependent that they lost the ability to exist independently. We now refer to these as mitochondria. This explains why mitochondria have its own DNA, why mitochondria have its own ribosomes. And this is why mitochondria are the powerhouse of the cell. It's where all the ATP production occurs. So that explains that very nicely from that. Now, independently, there were photosynthetic bacteria also living in this soup, and some of these photosynthetic bacteria got engulfed by cells, and these became the ancestors for any of our plant cells that are capable of photosynthesis. The bacteria became the chloroplasts that we find in plant cells and eukaryotic cells. So again, this is a theory based on a lot of different evidence that kind of explains how this happens. Again, a theory in science is something where a lot of evidence points to one answer. It is not a perfect thing. As we learn more and more, they can be revised, and the more evidence we have, the less likely it's going to be revised. There are some holes. We can't explain all of this of a formation of a eukaryotic cell based on the endosymbiotic theory. So who knows? But at this point in time, we're going with the most knowledge we have, and this is what we have to explain the differences and the similarities in prokaryotic cells.